Hello and welcome to today's lesson on adding, subtracting, and multiplying radicals. We'll also look at how we can estimate a radical based on perfect square values. So we look at some of these examples we have here on the first slide. When we look at the square root of 8, we want to understand that the square root of 8 is in between two perfect squares. It's in between the square root of 4 and it's in between the square root of 9. So we know that the answer for the square root of 8 falls somewhere between 2 and 3. It's probably going to be a little bit closer to 3 based on 8 being closer to 9, but all we're trying to do here is get a good estimate of the values so we can work with them as well. So we look at the square root of 37 in between the perfect squares of the square root of 36 and the square root of 49. So we know that the square root of 37 as a value falls somewhere between 6 and 7. Okay, so now if we want to put values in order from largest to smallest or smallest to largest, what we always have to do is we have to think about those estimation values. So we know that the square root of 11 is in between the square root of 9 and the square root of 16. So we know that it's in between 3 and 4. Let's change that value there. So we know that this number is between 12 and 9. So we've got 9 on the low end, 12 on the high end. Okay, when we're looking here at square root of 3, square root of 3 is between square root of 1 and square root of 4, so it's somewhere between 1 and 4. So we know that this number is between 4 and 16. Okay, so we're starting to get those estimate values looking at the ranges, and some of these ranges, of course, are going to overlap, and if I wouldn't make a math mistake on this one, we'd be in a little bit better shape between 1 and 2, 4 and 8. That's a little bit better. You know, it's 6:30 in the morning here, so just trying to shake off a little bit of that sleepiness. Square root of 7 is in between the square root of 4 and the square root of 9, so between 2 and 3. So we know that this value is between 4 and 6. Okay, so we're really starting to get a close estimation of these values based on the numbers that we're looking at. Same thing here, finishing up, 5 square root of 2. We know that this is going to be between 5 times square root of 1 and 5 times square root of 4. So we're between 5 and 10. Okay, so now we've got our estimation values. We can tell pretty much 3 square root of 11 is going to be our largest value just based on the range, and looking at where that value lies helps us know, is it going to be on the low end or on the upper end of the values. You know, so when we start, the hard part is looking at these middle two, 4 to 6, 4 to 8. If we're not exact, okay, then what we would have to do is we would have to go through and do the estimation, because these aren't necessarily popping right out as to the order of values. Pretty sure that 3 square root 11 is one of the upper values, because when we look at 5 square root of 2, this one's going to be below 10. 10 was that upper boundary of that value. And then we've got these 2 in the middle. This one's going to be closer to 8. This one, 7, is pretty much right in the middle. It's a little bit closer to 6. Okay, so if we could put these in order based on what we see here, 2 square root of 7 is probably the lowest one. Okay, it's between 4 and 6. It's a little bit closer to 6 probably than 4, just based on 7 being closer to 9. Okay, then we would look at our next one, 4 square root of 3. Square root of 3 is going to push us a little bit closer to 8. Okay, now what we'll have to do is we'd have to see where that 5 square root of 2 fits in. Even though it has the upper boundary of 10, okay, it's probably not going to be quite that high. Okay, 3 square root of 11 is probably going to be our largest one. Okay, but we want to always think about it in estimation terms first, and then we can go through and check in the end. So 3 square root of 11, if the calculator is going to work here. Okay, so 3 times square root of 11. Okay, we get 9.9. Okay, let's do 4 square root of 3. Okay, 6.9. 2 square root of 7. Okay, 5.2. So we were right in organizing those two. 2 square root of 7 is less than 4 square root of 3. Okay, and now our last one, 5 square root of 2. Let's try that again. 5 square root of 2 is 7.07. Okay, so we've got a 5, 6, 7, and then we have that last one, which was 9. Okay, so we would move this one down. So when you're trying to estimate and trying to organize with square roots, it's not always an easy task. What we'd have to do is look at the ranges, and then worst case scenario, we could use technology to help us find that value. Now, when we multiply radical values, what we have to understand is numbers multiplied by numbers, radicals multiplied by radicals. We really have to keep them in separate pieces. So when we're looking here, square root of 3 times square root of 2, they're both radicals, so we keep it as a radical. If you want to have an intermediate step, the intermediate step is you put them both inside one radical and then multiply it together to finish. You know, and here we've got the square root of 5 times the square root of 5. Okay, put them into one radical, square root of 5 times 5, square root of 25, and then you're always looking for perfect squares. Is there a perfect square that you can pull out of that value? And in this case, there is. Okay, now when we get down to this bottom set, now we've got constant values and radicals. So what we want to do is reorganize it, constant times constant, radical times radical. So we've got 3 times 2 is 6. Now when we multiply our radicals, we get 18. We don't want to stop here because there is a perfect square that can be pulled out of 18. So what we're doing is even though we multiplied them together, now we're going to pull them apart based on a radical value that's a perfect square. So we can go through and finish completely in simplified form. Okay, looking at our last example here, 7 square root of 3 times 7 square root of 3 when we square. Okay, we're just multiplying a value times itself. Then we reorganize. Okay, and we can finish by multiplying constant by constant, radical by radical underneath the root sign. And then if there is a perfect square, then we would want to complete that. And as early as it is, I'm going to use the calculator for this one just to be safe. Okay, 49 times 3 equals 147. Okay, now, our next skill is, multiplying and simplifying. So once again, when we're looking at values, the first thing that you have to do is be able to pull out any perfect squares. So 52 has at least one perfect square that we can pull out. Okay, I'm just looking at the simplest form. I know I can pull out a 4. Okay, when I do that, I'm left with 12. Okay, so 4 times, not 12, 4 times 13 is 52. Okay, 13 is a prime number, so we can't pull any more perfect squares out of that. And then we've got 5 times 9 times 2 times square root of 13. So we've got 10 times 9 is 90 square root of 13. Okay, so you're always looking at, can you simplify the radical? Once you've simplified the radical, then you work through to finish. Okay, now when we have a string of values like we do here in the upper right, what we want to understand is we're just multiplying all of the numerator values, and then we multiply all of the denominator values. And then once again, if you can simplify, okay, you want to pull out any perfect squares and square root those values to go from there. Now, 21 over 12 isn't the simplified version. I can cancel the 2 3's or divide out the 2 3's to equal 1 and end up with a 7/4. Okay, we do want to have that answer in simplest form. Okay, now, last example here, we got to think about order of operations. Okay, order of operations, we have to finish the parentheses first. The hard part is the radicals are different. So unless we can get the radicals to be the same, we can't combine those values. Okay, in this case, we can get them to be the same because we can separate out a perfect square from the square root of 12, and I'll be left with a square root of 3 value once I finish that up. Okay, don't forget the leading 3. So we've got 2 times square root of 3 minus 2 square root of 3. Okay, now we can finally finish the inside. We've got 4 square root of 3 minus 2 square root of 3. So we've got 2 square root 3 for that value. And then, once again, it's always just number times number. Okay, we don't multiply by the square root. It's almost like a variable x. So we end up with 6 square root 3. Okay, now, last situation that we're looking at here, dividing radicals. And once again, when we divide radical values, the first thing that we have to do is we have to look for and pull out any perfect squares that we can to be able to simplify it down and get it into that same radical form. Or we can separate radicals and divide out the radical. Okay, so we have 3 square root of 5. And in this one, there's not a perfect square to pull out of square root of 35. But what I can do is I can separate the square root of 35 into the square root of 5 times the square root of 7. Okay, by doing that separation, I do get a value that divides out to equal 1. Okay, so we can reduce this fraction. Okay, 3 and 9, we can divide both of those by 3 to end up with 1 and 3, and then all that we have left is the square root of 7. Okay, similar situation. We look over on the other side. Okay, we want to be able to separate values out as well as possible. In this case, okay, once again, we can't take out a perfect square. Perfect square, we want to find radicals that are similar. And I can see that both of these are going to be multiple of 5 values. Okay, so you're just looking at what radical can you separate out. Square root of 7, square root of 5. 45 is the square root of 9. So we do have a perfect square there times the square root of 5. Okay, but once again, you're trying to find that radical that can reduce for you. Okay, square root of 5's divide to equal 1. Square root of 9 is 3. So I've got 21 times 3 on top. 7 square root of 7 on bottom. And then once again, we're looking for values that simplify. I can divide both top and bottom by 7. To get it into its simplest form. Okay, now, like our last lesson, we talked about the fact that we don't necessarily always want radicals in the denominator. Okay, so this could be a possible answer for you here, but there is a second possible answer that is, mathematically a little more accurate, and it's what we call rationalizing the denominator. We don't want the denominator to be a radical value. So we multiply it by itself. Now, we can't do that just by the bottom. We also have to multiply it by the top value. Square root of 7 times square root of 7 gives you 7, and then on the top we'll have 9 square root of 7. So both of these answers are equal to each other. Okay, this one is the slightly better mathematical answer. I believe we accept both. Okay, but you do want to get into the habit of rationalizing your denominator value. And that is our lesson for today on multiplying, adding, and dividing radical values, along with estimating radical values. Thank you, and have a good day.